This conference will now be recorded.
Okay. Good morning, friends. In this EduDataBricks Master Program, in today's session, we'll talk about Pyspark introduction. So, so in today's session, we'll talk about what is Spark, what is Pyspark, Spark versus MapReduce. What is the difference between Spark and MapReduce? Why everybody is moved from MapReduce to Spark? Why? What are the important features of Spark? Why we need to use Spark? Then real-time data processing versus batch processing. What is meant by real-time data processing? What is meant by batch processing? Spark in-memory versus MapReduce. Okay, Spark is going to process all the data in the memory, but MapReduce is going to use complete hard disk. What is exactly it is, we will discuss. Then storage level, memory only, storage level, memory and disk only. So different storage levels we have, we will talk about all those different storage levels. Next, what is distributed computing framework? So distributed means you are going to distribute the data and you are going to compute it. Okay, so what? Okay, next. So Spark APS versus MapReduce. So different ways to write the code in Spark versus MapReduce. Databricks supported APIs. What Databricks? We can use Databricks. So what all languages Databricks supported? That is nothing but what all APIs Databricks supports, what all APIs Spark supports. Okay. Then difference between Spark and MapReduce. Spark distribution, tools required to write a code in Databricks. Okay, so these are the things we will discuss today. Today completely theory. Tomorrow also you will have a theory. Day after tomorrow you will have the Spark architecture. Okay, next 3 to 4 sessions we'll have only theory. Clear? Let's move on. So Spark is how many of you know Spark? Anybody heard about Spark? Everybody might have heard about Spark, but anybody heard about any future of the Spark? Any futures of the Spark? Anybody heard about it?
Yeah, I have heard.
Distributed computing.
In memory computing.
Okay, in memory computing. Okay, next. Any other?
Distributed computing.
Okay, 2 points.
We have
Okay, so you people said 2 points in memory and distributed computing, whatever. Now, what is meant by in memory? What is meant by in memory? What is going to happen when you say Spark is in memory?
data is loaded onto the memory, onto RAM, and then processed. So there is no between any maps and stages, data is not written back to the hard disk. So, so there is a lot of time saved in this.
Okay. What about distributing? Distribution means?
We will have multiple nodes. So a single query that we pass will be distributed to all the nodes, and the computation will happen parallelly in the multiple nodes, and we'll get back the result quickly.
Okay, good. So very simple. So first, when you say Spark is in memory, okay, so you say A equal to 10. This 10 will be assigned to A, right? So when you access A, you will get what? Value 10. But this 10 and this reference variable A is stored where? Where these two are stored? Basically, these two will store it in a hard disk if it is a MapReduce, but if it is a Spark, these values will be stored it in a memory. So when you access this variable, it will fetch this particular value very quickly because it is accessing this particular value from the memory. So remember, when you are accessing data from the memory, which is 100 times faster than accessing same content from the hard disk. Okay, you have some file which is there in hard disk. If you are trying to read this particular hard disk, if it is taking 100 minutes, If you play same file in the memory and try to read it, it will take just 1 minute. That's why if you look at Google and all, they will mention Spark is 100 times faster than MapReduce. The reason is MapReduce completely uses the hard disk. Spark completely uses the memory. Clear? All of you clear? First one. First thing is clear to all of you.
Yeah.
Yes. I mean, when we have large number of code, I mean, will we maintain large memory RAM?
Yes, so you will come to know, because when you are persisting and all, right? So what happens is, example, Spark is lazy evaluation. You know what is meant by lazy evaluation? All those wishes we will discuss tomorrow. So you are reading, you have written the read code, and then you are applied filter transformation, then you applied select transformation. Okay, do you think all these are executed as soon as you write and execute? If you execute this line, it will read the data and assign into this particular variable, data frame or RDD, or after filtering whatever result is there, that is assigned to some df1, and after select, it will assign to df2. Do you think this operation finished and it assigned data to df1? After filter, it assigned to df4, df2, or whatever. After select, it is assigned data to the df2. Do you think all this way, like all these particular data from variables are loaded with the data? Remember, no. The reason is all these are transformations. Transformations will not execute until you perform the action. Okay, when you perform the action, what happens? First, it will read the data and it will do the filtering. Once filtering is done, data will no longer be here. Okay, data will come to the filter. So once the data is came here, then it will come to the select. When you have performed select and you stored in a df2, df1 will not have any data. Understood? So like that, so all the transformation will keep moving. Suppose when you are accessing df1, what happens? You will still get the data, but it will recompute. It will read the data from here and it will apply filter and it will just give you the df1 data. Okay, I'll repeat this point. It is very, very important. Let's say you have 1 GB data. You have only 1 GB memory. So how you will process it? Okay, let's say you have 2 GB memory. Okay, how you process 1 GB of data? See now, first when you read the 1 GB data, okay, this is the df1. You read the data. Okay, this is a simple df. Now let's imagine this is a df1. What is meant by df1? You read the data and assigned created the data frame. Now when you apply a filter transformation, again some data will be there in a df1. Now here 1 GB already in the memory. Now some 0.5 GB again in the memory. So memory will get full and you will get out of memory exceptions if you are not clearing the previous variables, meaning whatever data you are referenced with this df, right, it should be removed as soon as you calculated this df. As soon as you calculated this, it should be moved into the another df. Okay, if you calculate any select transformation or whatever transformation you use, after that you will assign the data to the df3. Then this particular thing also you need to clear from the memory. If you're not clearing all these things, here 1 GB, here 0.5, here 0.5, so 2 GB already full, how you will process it? You will not be able to process it, right? That's why what happens, first you assign data here, the data will be in this. Once you apply filter, so filter cache the filter results df1. Let's imagine this df will be cleared from the memory. Getting, friends? Are you getting what I'm trying to tell you?
Yes, yes, got it.
Yes.
I mean, whatever the action that we do previously, that will be erased and the data will be saved in the new data DF1.
Exactly, that will be erased. That will be erased. Okay, now question is like this. You have a transformation 1, you have performance transformation 2, you have performance transformation 3. Okay, now you have a data here, you have a data here, now you have a data here. Now you may ask, I created transformation 1, transformation 2, transformation 3. If it is erased, if the data is erased at T2, if the data is erased at T1, even when I access T1.show, how it is showing the data? Can you tell me now if you understood? How it is showing T1.show means it is showing the data, how it is showing? When I ask T1.show, how it is showing? Tell me. Again, it will read the data. Suppose if I say T2.show, what happens? Tell me.
Again, it will
It will
process
read
and
the
filter.
data. It will do the filtering. T1 and T2 performs again. Again, it performs the T1 and T2. Got it?
Okay.
Got it? So as it is going to erase, the data, so you can do one thing. You are understanding my writing. T1, transformation 1, transformation 2. Whatever data we have, this is the common data which is used in T3, T4, T5, all other transformation. Now what I need to do is, I need to see every time reading data, filtering data and getting this data. Instead of doing this much, I don't want to erase this data. Is there any way? Very good. So there, cache or persist. What we need to do? Cache, or we need to do a something called persist. There are two functions. First important entry question, please note down everybody. The difference between cache and persist, everybody will ask you. You have to bring the answer for, you just look at the Google and note down the answer and let me know the answer tomorrow, okay? Then I will discuss, okay? Cache versus persist. Simple, cache has the default storage, persist has some storage levels. So few storage levels I'll cover today. Later you will come to know remaining storage. How many of you got this? This is very important concept. Clear, friends? Everybody is getting? Feel free to ask if you need one more time explanation. I'm ready to explain. Let's move on. Spark is an open source software developed by UC Berkeley Rad Lab in 2009. It was released to the public in 2010. Spark has grown in popularity and is used through the industry with an unprecedented scale. So unexpected way, like industry has adopted Spark for their analytics. Apache Spark is an open source distributed general purpose cluster computing framework. A lot of words are there here. These are open source. What is meant by open source? You have to be a little bit quick.
Anyone can make modifications and use it.
Very good. Yes, open source means you can just take the Spark code, you can make the modification and you can use it. Distributed. So let's say you have 100 records in a file. Okay. You will have the 4 servers in backend. Now each server can able to, now 4 servers you need to use. What you will do? You will divide these 100 records into 4 parts. And you will give first 25 to here, second 25 here, third 25 here, fourth 25 here. So this is nothing but a distributed. So you have distributed entire data into all these 4 worker nodes. These 4 worker nodes, we will submit the framework. That is nothing but our business logic. What it has to do with this data. It will perform, these servers will perform the logic. It will return, it will write data back to the same storage or from other storage or whatever. We already know how to connect to the different databases and different storages. Cluster computing framework. As I mentioned, cluster. What is meant by cluster? Cluster means group, isn't it?
Group of nodes.
So Cluster computing framework means group of computers are going to work for a general purpose. Okay, those all are going to work for a single task. The common goal is to execute those transformations. The common goal for all the cluster nodes means a group of computers, is to execute our business logic that we are submitting. Okay, that business logic is nothing but a framework. That framework we are going to submit on this cluster computing. So this cluster computing is going to perform a task in a distributed fashion. Spark provides an interface for programming entire cluster with the implicit data parallelism and fault tolerance. So these two are the Spark features: data parallelism and the fault tolerance. Got it? Data parallelism means, so you are distributing data parallelly, all the data is going to process it. That is nothing but data parallelism. What is fault tolerance? Anybody know what is fault tolerance?
Since we are computing on multiple nodes, I mean, very less chance of failures. Even one node fails, another node will pick up and will execute there.
Exactly. So, okay, all the transformation order will be saved. Okay, all the transformation order is saved. How these transformations are executed. When you are performing transformation 5, one of the node is down. Here 1, 2, 3, 4 nodes are there. This is down. What data it is processing, you don't know, but you no need to worry. So whatever data you lost, there is a fault here. There is a fault. Cluster is one of the cluster node is down. That is a fault. You need to tolerate. How you will tolerate? So it identifies what data it lost. Maybe it can compute only last to 25 records. It will read and it will do T2, T3, T4, T5 and it will get it. Otherwise, if you have somewhere here you have cache data persisted from this particular place, it will get it directly, because it knows what all things it has to perform. Once this node is up, it will pick. If this node is not available, it will pick other nodes. Other nodes will pick this transformation. Clear? Apache Spark is a fast real-time processing framework, and it has been proven to be easier and faster than Hadoop MapReduce. Why it is faster? Because it is processing data in the memory. That's why it is faster. Simple. It is the area of big data. Practitioners need more than ever fast and reliable tools to process streaming of data. See, nowadays everybody want the food which is going to which can be prepared in a 10 minutes, which can be prepared in a 5 minutes. See, nowadays we are not ready to wait for 1 hour, not only for food, not only for food, for anything. You will go to YouTube. Let's imagine you are trying for some, like you have some clarifications required, you are searching for that particular clarification in YouTube or documentation. You will go to one of the website. If you're not able to understand, you'll read 2 lines. If you're not able to understand, you'll not wait even. You will not try to read one more time. You'll just go to the next site. Similarly, you will try to watch one video. If that video is not interested, or if the videos keep on buffering, then you will stop. You will go to the another video, something like that. Nowadays people don't have the patience, I can say. So people want everything to be happen very quickly. So that's why business should be responded as per the people need. So as all the people required response very quickly. Example, you will go to any bank, or you are trying to make a transaction through phone pay. If it is taking more time, nobody is going to use a phone pay. Everybody will go for the Google Pay. If Google Pay is very slow, people will adapt to some other application which is faster, right? See, nowadays, maybe outside, I'm not sure, but in India, 90% of the people are using phone pay and Google Pay. Why not they are visiting the bank branches? Why they are not using net banking? Because Phone Pay, Google Pay is very easy. Within just 10 seconds, you can make the transactions. Very simple, and it will respond very quickly. So that's what people are looking for nowadays. Similarly, if you consider any business, our business application, we need to design in such a way that those should be responded very quickly. Okay, that kind of a service is Spark. Spark will respond quickly. It will process your data quickly. Okay. Apache Spark was introduced as it can perform stream processing in real time and can also take care of the batch processing. MapReduce can do only batch processing, but Spark can do batch and real-time data processing. But before that, so here I'm saying MapReduce is not suitable for real-time data processing. First, what is the difference between real-time data processing and batch processing? Anybody tell me what is the difference between real-time data processing and batch processing?
Batch processing is processing the data of a particular period, maybe last 1 day, 10 days kind of period data, wherein batch processing is continuously reading the data.
Okay, understood, friends. That's correct. Remember, real-time data processing means so you will go to the ATM, you make the payment. Sorry, you have withdrawn the amount, right? So immediately it is going to reflect in your account. So that is nothing but a real-time changes. Immediately it is going to happen. Example, I want to transfer some amount. Then if you look at in net banking and all those things, what happens is they will ask you after adding the new user, you need to wait for 30 minutes. Meaning these 30 minutes, within these 30 minutes, they are going to do some kind of a processing to check whether these are a right credentials or right details or not. And so ATM, all the transactions that are happening in ATM is a real-time data processing. So as soon as you make the transaction in ATM, the details will be reflected in your account. It will process it immediately. Now let's take your credit card bill. When you'll get your credit card bill, when we will get credit card bills, month end, right?
Monthly.
Month end, they will tell you, okay, these are the things we have done. That is the batch. So they are going to collect all 30 days data and they will generate a bill that they will process at the month end. That is a batch processing. See, batch processing means it can be hourly also. You can collect the data for 1 hour and you can process. This is also batch, but it's hourly batch. If you are processing daily, daily batch. If you are processing weekly, weekly batch. If you are processing monthly, monthly batch. Meaning month data you are collecting and processing at once. Real-time data processing means, remember, real-time also, it's not a exact real-time. Most of the services supports near real-time. Near real-time means it will collect 1 minute data and it will process it. It will collect 1 minute data, it will process it. It will collect 1 minute data and process it. So Spark is not real-time. Spark is a near N. This is N. Okay, near real-time. But here we will write it as a real-time only. But Spark is not real-time. It's a near time. Okay. Apache Spark supports interactive queries. You have seen in Databricks notebooks interactive queries. It is we can able to execute. Right? Apache Spark has its own cluster managers where it can host its applications. So different cluster managers we have: Yarn, Kubernetes, Mesos. Different things are there. So yeah, so you will come to know those things when I'm discussing the architecture. So Spark leverages Apache Hadoop for both storage and processing. It uses HDFS, distributed file system, for storage. It can run Spark application on YARN as well. See, MapReduce can able to read data only if it is there in HDFS, Hadoop distributed file system. But Spark, it can able to read data from Hadoop. It can able to connect to the databases. It can connect to any other storages you have seen, right? So it not only connected to the data like to Gen to Blob and all those things, it also connected to the Cosmos. It also connected to the SQL data warehouse, SQL database, all those things. Okay. Any questions in this?
No.
Okay. So if no, let's move on. What is Pyspark? Okay. So many people have a confusion. What is Spark? What is Pyspark? What is Pyspark? What is Spark?
If
I've
Spark
heard
is
that it is an API to Python API to Spark, but I don't know what it really is.
I think Spark is an architecture and PySpark is a library or script where we used to read the data and process.
Remember one thing, Spark supports 4 languages, okay? Scala, Python, R, Java, even SQL as well, okay? Now, when you say Spark, by default, Spark is written in the Scala. When you say Spark, you need to understand people know Scala, meaning they're going to write a logic in Scala. Logic in Scala. When somebody says PySpark, meaning they are going to write a logic in a Python. They are going to write a logic in Python. If somebody says Spark R, if somebody says Spark R, so that is nothing but they are using the Spark. Got it? So maybe like remaining Spark means Java also people may use, but they no need to mention Spark Java or something. If they say Spark, they may use mostly 99% Scala and sometimes they will use Java. You can ask them which language. So in Spark, if you're using Python, that is nothing but a PySpark. Now you can see the point. We are going to use a Python API. You see, PySpark is a Spark library written in Python. You understood? PySpark is a Spark library written in Python to run Python application using Apache Spark capabilities. What are the Apache Spark capabilities we discussed in memory, parallelism, fault tolerance, all those things? Okay. In other words, PySpark is a Python API for Apache Spark. PySpark is nothing but a Python. Okay, using Python API, we are going to run the Spark. That is nothing but a PySpark. Using PySpark, we can run applications parallelly on the distributed cluster. As we know, we can run the applications parallelly. The reason you have multiple worker nodes which are going to process the data parallelly. Next, Spark basically written in Scala. See, Spark basically written in a Scala. Later on, due to its industry adaptation and the demand, the market demand, its API PySpark released for Python using Py4j. So initially Spark is released only with the Scala language. Later with market adaptation and the demand, Spark team has developed the like some APIs like Python API, SQL API, R API, all those things to write the Spark code. Okay, meaning you can write you can write Spark code in Python or Java. So to support all these things, they have developed these particular APIs. Okay. So using Py4j, what happens is our Python, our PySpark code will be converted into the our Java objects. That's why Python for Java. Py4j means Python code will be converted into a Java object, because remember, whatever you do, everything base is Java. Even though it is a Scala, Spark is
I cannot hear. Can you hear?
No, I think there is a problem at Malaya and network problem.
Okay.
Hello, able to hear me now? Hello, able to hear me now?
Yeah.
Yes,
Yeah, yeah. Now okay.
Where we lost, friends? Where we lost?
we were on Pyspark. Yes.
After Pi
Only this
4J,
point.
we didn't hear anything.
Okay. Okay. So you can see pi 4j. Okay. Spark basically written in Scala. Later on to its industry adaptation of the thing completed, right? Pi 4j is a Java library that is integrated within Pyspark and allows Python to dynamically interface with JVM object, Java Virtual Machine objects. Hence, to run PySpark, you also need to install Java along with the Python and Apache Spark. You understood? Meaning, even though you are writing a PySpark code completely, Python code with Python syntax for writing the Spark code, but still you need a Java because ultimately, even though you are writing your Python code, this Python code should be converted into Java objects. So for that, we are going to use a Py4j library. It's a Java library which converts your Python logics into the Java objects. Understood? Got it, friends? Even Scala, even if you write the code in a Scala, Scala code also should be converted into Java objects only. Okay, clear? Now,
Yes.
Spark versus MapReduce. Now you see, big data, when big data comes, Hadoop came. So you have two things. Storage framework you have as Hadoop distributed file system. That is nothing but HDFS. And the computational framework, you have YARN, yet another resource manager who is a cluster manager, who will manage the entire cluster. On YARN, we can able to submit our business logic. Okay, now you see MapReduce programming. MapReduce is a programming. Your data processing, meaning here you will have the logic, you will develop the logic in MapReduce. That logic you will submit on this cluster manager who will actually compute this. You understood? So we have a data here, Hadoop. You have two things. You have a data, you have a computational. You have a data, you have a computational. Now, using this data, it can do something, but what is that something? So that is depends on the requirement, depends on the business logic, business requirement. You need to write a logic. That logic, when you submit on this particular computational framework will read data from HDFS and it will process that particular data and write data back to the HDFS. Got it? Here we are using only MapReduce, and remember, if you are using a MapReduce, only your data must be there in HDFS. If your data somewhere else, MapReduce will not be able to read it. So that's why your data must be there in a HDFS. Now let's go with the Spark here. In same big data, if you take a Spark, storage frameworks can be a HDFS, any cloud storage, any other database. Cloud storage, we have seen storages, databases, data warehouse, we connected, right? So any storage framework. Similarly, any computational, you have yarn, standalone, source, different computational frameworks, you have anything you can use. By using Spark programming, you can read data from any database, any storage, and you can execute on any of this particular computational framework. Got it? Everybody's clear?
Yeah.
Here,
Clear.
computational framework means you said yarn, all those things. I mean, you said it'll. I mean, what does it do? Computational frame yarn standalone means.
Computational framework means these are cluster managers who will manage your cluster. The entire computational framework will be managed by these particular cluster managers.
So a particular
Your
task
entire
to be assigned to which node? To which node we need to assign that?
No. So how many computation? See, you have multiple nodes. Okay, you will have a driver node, worker node. Driver node will drive entire execution, but this driver node, this particular worker nodes, all this communication, managing everything will be taken care by these cluster managers. Any of these cluster manager, okay.
Okay.
So real-time data processing versus batch processing. See, real-time data processing means real-time. So MapReduce supports real-time data processing and batch processing. No, see, it's a red, meaning real-time data processing is not supported by MapReduce. It supports only batch processing, but Spark supports both real-time and batch processing. You know why it is not supported by real-time data processing? Because it is going to process data in the hard disk. It is already slow. How, if it is a slow, how it can able to bring the real-time data? As soon as data comes, it has to process it quickly. So that is not possible in MapReduce. But Spark is going to use the in-memory. As it is going to in-memory, it will be possible in Spark to process the real-time processing, or you can say near real-time data processing. Okay. Real-time data processing versus batch processing. Okay. So the difference you can see, where a group of transactions is collected over a period of time, it may be 1 hour of time, 1 day, 1 week, anything. In this process, at first, data we will collect, entered and processed. We will first collect the data, we will save somewhere, then we will process it. Batch processing takes, okay, so that is the first definition. Let's come to the real-time data processing. Real-time processing involves continuous input, process and output of data. Continuously data comes, you need to process it and you generate the output. Batch processing takes more time to process because huge data you need to process at once. 1 day data you need to process at once, 1 month data you need to process at once. So that's why it takes more time. Real-time processing means it processes in a short period of time. It processes in a short period of time means it processes data very quickly because it's a small amount of data. Example, transaction of credit cards, generation of bills is the example for batch processing. Real-time processing means bank ATMs, customer services and the radar system. Radar system means while flight is in the air, so you need to track how it is moving and all those things. Okay, altitude, all those things you have to check. Advantage of the batch processing is an efficient way of processing high and large volume of data. Advantage of the real-time processing is in real-time processing, information is always up to date, hence it makes the organization able to take immediate actions. Something happened today, if you process this data tomorrow, tomorrow you know what happened yesterday. Okay, tomorrow you will come to know what is happening today, right? So it's a delay here in batch processing, but real-time processing you will be up to date. Disadvantage: one-time processing can be very slow as you have a lot of data. Disadvantage: real-time processing is very complex as well as expensive processing because continuously you need to use the computational, so it is expensive as well as a complex. Real-time data processing, you can see here day one data you have not processed. When day two came, we have processed day one data. Okay, see here. So this is the input data: day one, day two, day three, day four. So day one you are not processing. There is no data processing on day one. Day one data you are passing on day two, and day two you are processing. Day two data you are processing on day three. There is a delay here, time lag, okay, in the batch processing. But if you look at the real-time processing, day one data immediately it will process, day two data immediately, day three, day four, day four. There is no time lag. Okay, immediately it will process the data. Is it clear?
Spark, which tool it use for real time?
Spark itself can process. Spark streaming is there one of the component.
Okay.
Spark in memory versus map reduce. You can see a map reduce, so limited speed. Okay, distributed computing framework, but Spark is high speed. Why? Because Spark uses in memory. Map reduce will not use the in memory, so that's why, like, with respect to the speed and all, map reduce has a limited speed, but Spark has a high speed. Spark in memory versus map reduce. You can see these are what disk or memory. So you read the data, your data still in the disk. You apply filter transformation, your data still in disk. We have select transformation disk, join transformation still in disk. But here, first you read the data, data will be loaded into the memory from hard disk. From storage, you read the data in Spark, the data from data will be in the memory. You apply filter transformation, you'll have a memory. You apply select transformation, your data in the memory. You apply join transformation, still data in the memory. Okay, user can cache data in the memory at any time. If somebody wants to cache it, they can cache this particular data in the memory permanently, because it is going to erase. To avoid that erasing of data, you can just cache it in the memory. Okay, clear? Let's move. Storage level, memory only. So you have RDD. When you say RDD dot persist of memory only, so it may persist data into the only memory. So whatever we, this particular RDD is divided into this. What are these? What are these? Quick. These are the partitions, because as I mentioned, 100 records, if you have 4 nodes, if you have 1, 2, 3, 4 parts will be divided 25 like that. Whatever data you have, that is divided into 2 parts here. So each part is storing in the memory. Okay, when you say memory only, so entire data will be there in a memory. So let's say memory is not sufficient. What happens in that case? See, memory and a disk, meaning if this entire partition you try to put it in the memory, this partition you put it in the memory, and while you are trying to insert, while you are trying to cache it in the memory is not sufficient for this partition, then you can write it into the disk as well. So that is the choice you need to take: memory only, memory and disk, whatever options you want to use, you can use. Clear, friends?
Yes.
What is distributed computing framework? Distributed system is a system whose components are located on a different network computers, which communicate and coordinate their actions by passing messages to one another. So all the nodes are there in a different networks, even though all the nodes are going to perform a task for the common goal. The components interact with one another in order to achieve a common goal. The common goal is to process the data, even though So each node got the different data. So each node is going to communicate and it will process the data. Three significant characteristics of the distributed systems are concurrency of components. Concurrency means parallelly it will process. Lack of global clock. Lack of global clock means, so there is, so first node may complete first, next compute node will finish little bit late, next compute node may finish the job data processing little bit late. So there is no time, there is no sync up here. So each node can process the data individually. Lack of global clock means we cannot say in 2 seconds this will finish, 2 seconds this may finish. No, this may take 2 seconds, this may take 3 seconds, this may take 4 seconds for processing. Okay, next, independent failure of components. If anything is failed, it is just failing this, it will not fail entire system. If node is down for some reason, only this node will be down, that's all. That's what we said. This is a, if any node is down, that is nothing but a fault. How Spark can tolerate, it can able to fetch this data from the source again, whatever data it lost. So example, there is a problem, you give these particular things to the master. Okay, 1 2 3, okay, 3 things. Now first will be passed to the first calculation is passed to the first compute nodes, 2 plus 1. This will generate the data at one time, this will generate the data at the output at one time, this will generate the output at one time. There is no sync. So all these things should generate the output at once, there is no guarantee, but all these three will start running parallelly. And if anything failed, only that particular calculation will fail. So if this node is down, 2 plus 2 4, that calculation only we will miss. Okay, so again it will recompute, it will know what data it lost, it will bring that particular data. Okay, Spark APIs versus MapReduce APIs. Spark supports Scala, Python, R, Java, and even SQL, but MapReduce support only Java. Got it? Spark supports Scala, Python, or Java, but MapReduce supports only Java. Databricks supported APIs. Databricks Notebook supports Python, Scala, SQL, and R. Python files supports Python. Jar file supports Scala and Java. So meaning, so you can do anything. So in notebooks, you can write Python, Scala, SQL, R code. Python file supports Python code. Jar files means any Scala and Java code will, with any Scala and Java code, we can create even jar files. So in Python notebook supports Python, Scala, SQL, and R. These 4 languages. Difference between Spark and MapReduce. See here, 100 times faster than MapReduce, faster than traditional systems. Data processing, batch, real-time interactive batch processing. Storage, any storage it connect, but MapReduce only HDFS. Memory, store data in memory, store data in disk. MapReduce stores data in the disk. Written in Scala, MapReduce is written in Java. Resource managers, we have standalone yarn, mesos, extra, but MapReduce has only yarn. Cost, Spark is costly than MapReduce because Spark uses memory. Memory is costly than hard disk, right? So that's why Spark is costly. Clear? Everybody's clear?
Yes.
Spark distributions, we have a Cloudera, Hortonworks, Azure Cloud, AWS Cloud, Google Cloud, anywhere. But we are using Spark in a Azure Cloud, that is in Azure Databricks platform. We are using this Spark. But Spark can be Spark computation can be taken from the Cloudera, Hortonworks, AWS Cloud, Google Cloud, even Azure Cloud. We are using from the Azure Cloud. Okay. Okay. Tools required to write a code in Databricks. If you want to write any Scala code or Java code, we need is Eclipse. If you want to write a Scala code and Java code, you can also use a IntelliJ. If you want to write a Python code, you can use PyCharm. Okay, but mostly 99.999% people are going to use the notebooks. So notebook supports Python, Scala, R, and SQL. Okay, that's all for today, friends. Any questions?
Just let me know if my understanding is wrong. So
Hmm?
Spark is basically, can you hear Malaya?
Yes, yes.
Spark is basically some architecture like a framework, right? But the programming language, it's not a programming language. We use Python,
Spark is not
Scala.
a programming language. Who said Spark is a language?
I was in that impression earlier.
No, Spark is a framework. Okay, so you can framework means like you are going to build a business logic with the Spark. That business logic, to build business logic in Spark, you can write Python syntax, you can use Java, Scala, anything. Okay.
Okay.
Any other questions, friends? Okay, fine. If no questions, that's all for today, friends. Okay. Thank you. Thank you.